Hi, so for today we are going to talk about Venn diagrams. This is a continuation of our topic about discrete mathematics or discrete structures. So let's get started. So what is a Venn diagram? A Venn diagram is a pictorial representation of sets. Last time or last video, we talked about sets and some operation in sets. But in another way of representing sets is through the braces, and of course through statements. But this time we are going to represent sets, okay, in what we call the Venn diagram. And it is a pictorial representation of sets in which the sets are represented by enclosed areas in the plane. So as you can see here, we have the circles here represents a set, and we have a rectangular plane here, rectangle, which represents the universal set. And the universal set U is represented by the interior of the rectangle, and the other sets are represented by discs or circles lying within that rectangle. So we all know that when we say a universal set, these are the set, okay? This is the set that contains all of the elements in the elements of the set inside the set A and set B. So for this, for example, we have this set A and set B here. Okay, we say that A is a subset of B based on the representation of our set, because the set A is inside the set B. It implies that set A is a proper, or I mean a subset of set B. And in the second figure, we have set A and set B. The set A and set B doesn't have any intersection, doesn't have any relation, or if it does not intersect, we call it they are disjoint. A and B are disjoint. So on the next one, we have the intersection of set A and set B represented, okay, represented by this shaded red area. Okay, so that is basically represented as A intersection of B, that shaded area. Okay, so again, visually we can see, okay, that they are meeting in this shaded area. It means they have what? Similar members within their set. And that similar members within their set is represented by that shaded area or the intersection. So to represent the combination of these sets, we shade the corresponding region. So for example, just like what I've said, in intersection of set A and set B, we have this shaded region as our intersection for the Venn diagram. So it means that this shaded represents the common members of set A and set B. And also, here's a representation of the set A intersection of B complement. So now we call this B complement. Sometimes it's says like this, or sometimes it is said like this. So all of this have the same meaning, which means the complement. Okay? And the complement, when we say B complement, okay, we have a set of B, let's say that's a 0 and 1. The B complement are the sets or the members, okay, not including B. Okay? So for example, if you have set A as 2, okay, so the not B is not, the 0 and 1 is not included. Hence, it is called complement. So the not B will be, or the B complement will be considered as the other elements, which is A. But in this, okay, we have the intersection, the shaded region is only this. Okay, and that is what this represent. The A intersection of B complement, or the B A intersection of B complement. So this represents the shaded area of A intersection of B complement. Why? Because the complement states that it cannot include itself. Okay? so that the intersection only becomes purely the values of A not shared with B. So that's the representation. Also, we can have a more complicated example of which we have B intersection of C represented by this shade, the B and C. So there, that is where the B set B and C meet. And it is in union, meaning combined, with the C intersection of not A. So intersection of C and A, for simplification first, the intersection of C and A is this region, okay, including this other also. But since, okay, since we have A complement, we are going to delete this shaded region. So we're going to delete this shaded region and leave it as blank because it is in terms of A complement. Okay, so that's why we have this Venn diagram represented by this shade of gray. So we have more examples. So if we have three sets such as A, B, and C, and we try to get the union of A and B and union of C, that is simply all of the sets, okay, combined. Okay, and if we get for letter B, we have A complement intersection of B complement intersection of C complement. That is just simply what? Okay, that is just simply A except the sets in A, except the sets in B, and except the sets in C. Okay, so that's the intersection. So, and that belongs to the universal set. Okay, the universal set is shaded except for A, B, and C, wherein the universal set are the members in the universal set. So in other words, it can be also A represented as A union of B, union of C, complement, because once we distribute this complement, okay, we will end up with this. Once we complement, we change also the union to intersection. So if we get the union of A, B, union of C, which is this, we will be getting this shaded. So if we complement that, meaning we complement, and that is equal to this, what we did, instead of shading A, B, and C, we are now going to shade universal set. And that is what the complement does. Okay? So for this, we have A complement. Okay? Okay? All the elements involving in all of the sets except the A. Okay? So that's why we have not included in the shade any of A, because that is the complement of A. All of the elements in B and all of the elements in the universal set included except A. Okay? And also we have this. We have A complement union of B union of C. So if we shade it except A, okay, so we'll be having this figure. So that's how you try to somehow, okay, convert this set information into Venn diagrams. So for any infinite set S, we let n of S denote the number of objects in S. So this is what we call the inclusion and exclusion principle, of which, okay, the inclusion and exclusion principle is denoted by this formula, where n meaning how many objects are there in S. That is the n of S. That is what is the meaning of n of S. Okay, so if we have A equals 1, 2, 3, 4, 5, 6, 7, and B 5, 6, 7, 8, 9, 10, we can find the n of A, or the number of objects in A, by counting the different distinct member of A. So we have 1, 2, 3, 4, 5, 6, 7. So therefore, we have n of A as 7. And for n of B, we're going to count the distinct members of set B. So we have 5, 1, 2, 3, 4, 5, 6. So therefore, we have n of B as 6. Okay? And from there, we can substitute it here, and if there is one given, if the intersection of A and B is also given, we can finally find the union using this formula. So check this, that this works from A and B from the example above. So upon getting the union of A and B a while ago, we have 1, 2, 3, 4, 5, 6, 7. We have 8, 9, 10. So we will be having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of objects in the union of A and B, N of A union B equals 10. So if we wish to find the intersection, it is also easy. We get the intersection of A and B. They intersect at 5, 6, 7. Okay, so these are both common. So you have intersection of 5, 6, 7, and the number of objects in the intersection is 3. Okay, so if we check from the following formula, we have N of A union of B equals N of A plus N of B minus N A intersection B. So we can finally found N of A union of B is 10. And then N of A is 7. So you have 7. N of B is 6. And N of intersection will be 3. Okay, minus 3. So you have 10 equals 7 plus 6 is 13 minus 3. 10 equals 10. So the formula is the same or proven to be true. Alright? Okay, so you can use this formula, the inclusion and exclusion principle. Nonetheless, by inspection, okay, of the different sets, you can already solve this given problem. Okay? Now for our next problem, we have note that if two sets A and B do not intersect, then we have the numbers of intersection or objects of intersection of A and B equals 0. And hence, the formula of the inclusion and exclusion principle reduces to this formula, wherein we don't have any minus of the n, okay, of the intersection of A and B, since it will be 0. So the union of A and B will now be just the number of objects of A plus the number of objects present or members present in the set B. Now, if we apply this to a set and its complement to get, we have the number of the objects of A complement will be the number of the universal set minus the number of the elements in A. So where U is the universal set. Okay? So for formula number 2, the shaded region below is the A intersection of B complement, and we have A intersection of B complement, intersection of A, and the intersection of B will be null set. So we reduce the formula to this. Okay, so these are actually just some of the formulas that we need to take more specifically the one we have here, right? So this is just additional information. So let's say that we have let A and B sets such that N of A is 10, N of B is 12, and the N of the union A and B is 15. Then how many elements are there in the intersection? So pretty much basic, the formula would be A union of B equals the number of objects in A plus the number of objects in B minus the number of objects of the intersection of A and B. So we are given NA, which is 10. We are N of B given, which is 12. We are given the union, number of elements in the union is 15. So by this formula, it's pretty simple. If I'm going to transpose it on the left side, this becomes N A intersection of B positive equals N of A plus N of B, okay, minus N A union of B. So that I can find the intersection. So I have N of A, which is 10, N of B, which is 12, N of the union is 15. So I have 22 minus 15, and that is 7. So the number of the intersection of the elements of A and B is 7. Okay? We have also seen it in our computation here. So let A and B be sets such that the number of A and B union is 20, N of B is 10, and A intersection of B is 5. Then how many elements are in the set A? So we are given the union of A and B, the number of elements, that is 20. The number of elements in B is 10. The number of intersection of A and B is 5. Pretty simple. We are asked the number of elements in A. So from the formula again, we have N of A plus N of B minus the intersection of A and B. So N of A is being asked. So now we have NAUB, which is 20, equals N of A, we don't know. N of B is 10. And the intersection is 5. So you have 20 minus 10 plus 5 on the left side if we transpose. 20 minus 10 plus 5. So this is gonna be 15, the number of elements in A. Okay? So that's the inclusion-exclusion principle. Whenever we are given the intersection or the three categories or the three given, we can easily solve for the other one that is being asked. Okay? See, this is the geometric representation of the exclusion-inclusion principle, wherein we have seen that the intersection is 5. So if graphically we draw, we have set A and set B with the intersection of 5. Okay? So, of course, in order for us to get the B, okay, in the set B, the elements only in the set B, we are going to minus that 5 with the elements that are present in the B itself, which is 10. So 10 minus 5, that is 5 here. Okay, for only the B. And also, we can use the same technique to get the number of what? The number of sets, or the number of elements in the set A. Okay? So basically, what we are going to do, since we have N of A as 15, and the common intersection is 5, so 15 minus 5, we can get 10 here. So that if we add, we will be having 20. And the number of elements in the union of A and B is 20. So meaning the total number of elements should be 20. Okay? So, let's try to solve another one. A survey of group of students revealed that 60 of them like at least one of the cereals, Frosted Flakes or Lucky Charms. So we have two kinds of cereals, the Frosted Flakes and the Lucky Charms, and there are 60 group of students. If 50 of them like the Frosted Flakes and 46 of them like the Lucky Charms, how many of them like both the cereals? Okay? So, we're going to solve this by this. The number of elements of Frosted Flakes is 50, as stated. And we have the number of Lucky Charms is 46, as stated. So, if you get the union of that, that should be 60. Because the union of both shows the at least one of the cereals, okay, is 60. So, if we do that to get how many of them both like the cereals, it denotes the N of the intersection of the Frosted Flakes and the Lucky Charms. Alright? So, if we get that, that would be simply from our derived formula, we have N of LC plus N of FF minus N of FF union of LC. So that's why we have LC as 46, and we have N of FF, which is 50 for the frosted flakes, minus 60, which is the union of FF and LC. So we have now 36. Okay? So that is 36 who both like what? Frosted flakes or and Lucky Charm. Okay? They both like the cereals. So for letter B, draw the Venn diagrams showing the results of the survey. So let's say this is Frosted Flakes, and let's say this is Lucky Charm. So the intersection of Frosted Flakes and Lucky Charms, okay, is 36. So meaning 36 both like it. Okay? Both like cereals. So how do we get the number of FF and the number of LC? It's pretty simple. Since we already have the number of Frosted Flakes, which is 50, we just need to minus 50 here. 50 minus 36 is 14. Okay, so that if we add 14 and 36, the number of Frosted Flakes both would be 50. And how about for the Lucky Charms? So since we have N of LC as 46, so 46 minus 36, it's simply 10. So that if we add 10 plus 36, that is 46. The total votes for the Lucky Charm. Now, if we add all of this, 36 plus 14 plus 10, meaning we have 10, 1, okay, 1 plus 3 is 4, 5, 6, we have 60, with a total of 60 students who participated in the survey. So that's the Venn diagram for the second one. Alright? So, let's try to have Venn diagram for 3 sets. So, a Venn diagram of 3 sets divides the universal set into 8 of non-overlapping regions. Okay? So, we can sometimes use partial information about numbers in some of the regions to derive the information about numbers in other regions or other sets. So, this is an example of a Venn diagram of 3 sets. Usually, the given lies here. The first given or the first clue lies here, wherein this shaded area of what I shaded is actually the intersection of the 3 sets A, B, and C. Sometimes it is the very first crucial information that you should look out whenever you are trying to solve Venn diagrams of 3 sets. And that is actually the intersection of A, B, and C. So what number is that? Okay? So that's the very first thing that you're going to look at. And out of that, okay, you're now going to look at the relationship of A and B, the relationship of A and C, and the relationship of B and C before you can finally come up with the conclusion of what is the remaining for A, B, and C. Okay? So the following Venn diagram shows that the number of elements in each region for the sets A, B, and C, which are the subset of the universal set U. So if we get the A intersection of B and intersection of C, we get 2, and that is the most crucial information we are looking. The B complement is the B except the B. So all of the elements in B, okay, except it. Okay? Except the B. So we now have 3 for the universal set. We have 2 plus 4. We have 10. So that is 19. Okay? How about for A intersection of B? Very simple. The A intersection of B is this. A intersection of B is this region. That is simply 3 plus 2, which is 5. For C, it's very simple. Add up all the values in C. So you have 4, 2, 1, and 2. Okay, so 4, 2, 1, and 2. 4, 2, 1, and 2, which is 9. And lastly, the B union of C. So all of the numbers in B, okay, and all of the numbers in C. Okay, so you're going to add. So you have 9, you have 3, okay, you have 6, which total of 18. So that's the relationship on how we are going to get the Venn diagrams for t-sets using the given numbers already. But in the real problem solving for Venn, you are given a worded problem, and then you are going to get a certain answer to a problem, whether how many both voted for the set A only. So you're going to get the answer for that. So you're going to draw your own Venn diagram. So for example, in this Venn diagram for t-sets, in a survey of 68 finite math students, so 68 voted. Okay. So 62 like the movie The Fault in Our Stars. So you have a set that's labeled as set F, Fault in Our Stars. 42 like the movie The Spectacular Now. So that is set S. And 55 like the movie The Perks. Let's label it as set P of Being a Wallower. 32 of them like all three movies. So meaning if they all like three movies, that is S intersection of F intersection of P, that is 32. So this is the value that we are looking for. 39 of them like both the Fault in Our Stars. So they both like Fault in Our Stars and The Spectacular Now. So F intersection of S, that is 39. Take note of that. And 35 of them like both The Spectacular Now and The Perks of Being a Wallower, 35. And 49 of them like both Fault in Our Stars and The Perks. Okay? So 49. Represent this information on a Venn diagram. Okay? So here is our Venn. First of all, I'll try my best to draw a big Venn for you here. Oops, I'm wrong because we have three Venn diagrams here, supposedly. So I'm going to use here. Okay, I'm just going to write. We have the intersection of F and P as 32. Supposedly, we don't know the values. Okay, let's just assume. Okay. So you have S and P, 35. You have F and P, intersection of P as 49. So they say that the intersection of all who like S and F and P is 32. This is the information that is very crucial. So we know the 32 already. They like it both, the three. Okay? So now, we have the information that F intersects S, okay, as 39. So this is the shaded region we are concerned, the intersection of F and S. But since we already have 32 and the total of the intersection of F and S is 39 and we already have 32 here, so we have, for the value here, okay, that must be 39 minus 7, which 39 minus 32, which is 7. So that if you add up the intersection, 7 and 32, you have 39. Alright? So how about for the S and P? We have 35. So for the S and P, this is the intersection, including that 32 that is being shared by the three set. So if we have 35 for the intersection, we already have 32 here. 35 minus 32, it means we have a 3 here. Okay? And we have already also the intersection of F and P. The intersection of F and P is here. We already have 32. Okay? And it says 49. So 49 minus 32 would be 17. So you would write 17 here. Okay? And in the last part, we are going to get the 3, the 6, and the 0 here. And the universal set. Okay? Those who don't vote. Okay? So let's try to solve. So saying we don't know still the value of 6, we don't still know the value of 0, we don't know still the value of 3, how did they come up with that answer? Okay, going back in our problem, So they say 62 like the movie The Fault in Our Stars. So those who voted, we have 69 voted they like as Fault in Our Stars. So in our information for The Fault in Our Stars, we already have 7, we already have 32, we have plus 17. So what we are going to minus, we are going to minus the sum of this into the total persons who like The Fault in Our Stars, which is 69. So this must be 32 plus 17, or 32, 17, and 7. This is 32. So you have 14. You have 16. 1. We have 56. I think it's 56. 7. 7, 14, 16. 1. You have 4, 5. 56 here. Alright, so we have 56. And sorry, my mistake. This should be 62, not 69. So this would be 62. So the remaining number of F would be 62 minus the combination of all in F. 62 minus 56, that is 6. So you already have 6 here. The same goes with the S. So 42 like the spectacular now. So we have N of S, okay, the 42. So that if we get all the summation for S, okay, we have 7 and 32 and 3. So that is what? 12, 1. So we have 42. So 42 minus 42, so 0. So we have 0 because all of the votes for spectacular now comes with what? With a vote that is also a vote in Fault in Our Stars, a vote in the P, and a vote in, of course, in F. So that's why there is 0 here. So last but not the least, how about for the Perks? Okay, it says 55 like the movie The Perks alone. So N of 55, N of Perks is 55. So I'm going to add 17 all of here. 17, 32, and 3. Okay. 17, 32, and 3. So it's very obvious. So I have 17, 32, and 3. So you have 10, 12, 1, 52. So the remaining here would be 55 minus 52. That would be 3. So you have 3 here. So that's why that is the Venn diagram for our set, for the 3 sets. Alright? Okay? So you can try this one. Okay? So this is for your assignment and for your reference of the answer. Okay? This is the reference for your answer. So you can check it. But first, you can solve this. Take note that you can, okay, you must take note the 21 number here, which like using all the 3 channels. Okay? So that is your very first information that you need to learn before you can go computing the values of the other parts of the Venn diagram. Okay, so thank you so much for listening, and I hope you learned something from this video. If you do like this video, please don't forget to subscribe to my channel and for more engineering subjects tutorial. Thank you so much and for listening, and good day.